Right. Okay. So, I see 30 people in here. I'll be waiting for people to join in more. Till then, let's just have some conversation. So, hello guys, and I can already see a lot of people talking in here. So, before we get into any of those introductions and what the session about today is, tell me how was the hack? Just tell me, did you enjoy the hack? Did you learn? Tell me something in the chats. I'm waiting for your response. What is that one thing you took away from this hack? Come on, guys. I need you guys to, answer me because, we've worked really hard on this event, and I'm pretty sure all of you worked really hard on your projects, and it'd be great, if we could get some sort of, you could write something down in the comments and, show us some sort of enthusiasm. And of course, during the entire session, as Raghav says, if you have any questions, feel free to drop in, right? And right. Okay. Um, I think there's a delay. I'll be waiting for people to write down in the chats. Tell me something. How did you guys learn? I can already see the numbers going up. That is amazing. That is amazing. All right. Everyone says they're excited. I'm actually so happy to see this sort of enthusiasm in the morning. It's generally people are really, sort of, what can I say, sluggish in the morning. People are not so excited, but I'm really glad to see people actually, so excited for this event. And believe me, guys, we have something amazing in store for you. Right now, I mean, the person who's going to come up when I read out his introduction, you'll know that, how enriching this experience is going to be. And yeah, we've been lucky to, have some amazing speakers this event. They have shared their great deal of knowledge with us, and all of you have shown us support during those speeches. And I'm pretty sure this one is going to be great as well. So I think I'll get into it now. I think there's a lot of people in here now. So let's just get into it, right? So let's just formally say hello to everyone. I know it's been a long night of hacking, and it is the final day of the hack, and I'm pretty sure you all have something exciting and nice to show us and review to coming up. But before that, we've had amazing sponsors this event. We had a lot of sessions on the first day, and right now we're going to have another sponsored session. So so before we talk about the sponsor and who the person is, one of the things that I wanted to talk about is cybersecurity, right? And I mean, at DSC VIT, we value cybersecurity a lot, and we even had an entire event on it. We had an entire CTF, and the upcoming sponsor actually was the title sponsor for the CTF. And I'm pretty sure you guys must have guessed it. The company that we're going to be whose event this is for is Crowdstrike. And let me just tell you a bit about cybersecurity and Crowdstrike if you do not know already. So there's a lot of really big organizations, right? Who and there's this one thing I've already always heard is that the next world war is going to be a cyber war. I mean, that is how important cybersecurity has become in today's world. And I mean, there have been big courses on it, and security research is booming. It's probably one of the biggest areas of research in computer science right now. So it is very important that whenever you have a company, right, and whenever you have a product, you essentially have to make sure that the your product is secure, because if it doesn't, those sneaky hackers will get into it. And when you see in these movies that people come on the computer and type some random stuff and then they say I'm in or something like that. So you don't want that happening to your company, right? And CrowdStrike is a company that excels at that. It is a platform that provides an extensive cybersecurity solution and makes sure that your business is product is saved from those hackers, right? So enough about CrowdStrike. Let me just tell you about the speaker who's coming up. So his name is Sudhakar, and he's an engineer with the Spotlight team at CrowdStrike, and he has over 4 years of experience around reversing exploitation, CTFs, and software development. I mean, this person is the whole thing you can about. I mean, you can talk about security, and I'm pretty sure he'll have an answer to every all of your queries. And don't hesitate to drop all of those queries in chat. He's passionate about exploitation. He's passionate about mathematics. He's been a chapter lead for Null, which is the open security community in Pune, and he has given local talks at Null meetups and B-Sides Delhi. And before I invite Sudhakar onto the stage, I'll just like to tell you that he's going to speak about getting into vulnerability research, which is a subset of security research. And I'm pretty sure that this is a really important and amazing topic coming up, and I'm pretty sure that you guys will love it. So, Sudhakar, I think he'll be joining the stage any second now.
Yep.
Hello, hello, Sudhakar.
Yeah. Hey, Hisham. Is my
Uh,
screen visible?
Not yet. I think it's visible now, right?
Yeah.
I
All
can
right.
see your
Sorry.
screen. Okay,
Sorry
all
about
right.
that. Yeah. So, hey guys. Good morning. It's your normal, you can say, talk. I would be presenting. Firstly, who am I? So that even if I babble something, you don't think that okay, this is some random guy spitting out something which doesn't catch up or whatever. So I'm Sudhakar. I work at Crowdstrike. I'm a content engineer. I'm based out of Pune. Right now, it's where I am. I graduated in CSE from IIT Indore in 17. I like to do a lot of reverse engineering. I love solving puzzles, even solving hard challenges in general. So even if it's a coding problem or it's a math problem, economics problem, I don't care. I just like working on hard challenges. If they're puzzling, that's good. So other than this, my personal choice of languages in the order of preference is assembly to C, then Golang, then Python. So that's pretty much it. Depending on this, if you have an overlap with the things that I do, you can definitely ping me up. I'll post my contacts later at the end of talk. So now, CrowdStrike. So since I work at CrowdStrike and this is a sponsored talk, I'd like to speak about it a bit. um, CrowdStrike is a leading cybersecurity company. Right now, it's one of the Nasdaq 100 stocks in such you have Nifty 50 in India. Similarly, in US, you have Nasdaq 100, the top 100 stocks, and you can say that it's in there with Apple, Google, whatever you want to see. So we are kind of the leading cybersecurity company in there. The main task that we do is we stop breaches. As Hisham already said, if somebody is saying I am in, we stop that. So nobody's gonna say I am into your PC or to your company's network or your home network or whatever if CrowdStrike is there. So that's what we try. So we have an environment of product called Falcon. So Falcon is a very small agent, or you can say software running on your machine. It collects some events, and based on that those events, it tries to do some actions which basically stop those breaches or never let somebody get onto your machine other than you. The infrastructure that we internally use here is mostly Go. Other than that, we have C++ and Python as well. So if you are interested in those technologies, you can join. We have a very large cloud team in which, because we have problems that we are solving at a very large scale in the cloud, so we definitely need that. So if you're into that, also we are hiring. So in India, we have a lot of roles. You can check out companies Workday, and you should be able to talk to Saurabh as well. He's present. If you post your questions in the chat, he might reply. All right. Yeah. So the title of the talk is vulnerability research and how to get into it. So first, I'll answer the question: why do you want to do it? So in vulnerability research, we don't have that much talent in India. There's a lot of gap in the number of positions that the industry wants, but there's lesser number of people from student side getting into it. So we use in terms of vulnerability research, we usually hire people with a lot of experience, which have been in the industry for, let's say, 5 6 years. They understand what vulnerabilities are, what the surrounding ecosystems are, but we want to be better at it, such that people who start their career just passing out of college, they should, or even in college, they should understand what vulnerability research is, what should you do to get better at it. Next thing is, you might like it because it's hard. Some people like to solve hard problems or challenges. Next thing is money. It definitely pays well. It pays better than an average software developer, is what I would say from my personal experience. Another thing is fun. So uh, you'll definitely have fun. Like if you are into this, then at some point in time you'll probably start having fun, and that's where like everything gets good. And next thing is fame. So vulnerability research, you like pulls out a lot of hackers which are very popular, some of which you might know, maybe say if somebody games like Pwn to Own, or people like GeoHot who actually hacked the PlayStation and stuff like that. So the most popular hackers, if you want to be one of them, you'll probably be upping your vulnerability research game. You'll be finding out more vulnerabilities or 0 days in different products. So that was the motivation. uh, that Yeah, that's pretty much it. It totally depends on you. If altruism, if you want to be a white hat hacker, save some people, that's also perfectly fine. So these next thing is, this is a very opinionated talk, so that means things that I've written here, they basically apply to me. But you can catch up with me later. I'll post my links, you can talk to me, whatever, and we can see how does it apply to you, what motivates you and stuff like that. All right. Next thing, what is a vulnerability? So vulnerability is the state of being vulnerable. That means something, some system, some code, some hardware, or let's say even your elevator in the society building, elevator in your college, if that has a problem, and it is kind of vulnerable such that you can arbitrarily stop or potentially stop it, or you can gain control of the whole system itself. That is basically what a vulnerability is. So we identify known vulnerabilities. So let's say I know that last month Google Chrome patched a vulnerability in the Chrome browser software. That means there was a problem with Google Chrome in such that an attacker would be able to trick you, or not trick you, just ask you to browse to a random website. And if that random website compromises the machine that you are using, it probably might be a vulnerability with Chrome browser. So every month people at Google work hard to fix those vulnerabilities, and every time they identify a vulnerability or they patch it, a CVE number is assigned. So CVE number looks like CVE dash 2021, the year that it was released, dash followed by a number. So to keep this to keep the book clean, or to identify vulnerabilities uniquely, every vulnerability has a unique CV number, for which you'll have to talk to the CV authority to get yourself some CV number. And hackers usually who report these vulnerabilities to vendors to get them patched such that nobody's exploited using these vulnerabilities. They have a large count of these CV numbers that they have boarded up on their account, and that basically you can say is kind of the boast that you can make in terms of vulnerability research. Now I'll show you what a vulnerability looks like. uh, this is a piece of code that I have written. It has a vulnerability. What I'm gonna do is I'm gonna wait for uh, I think most of you people, since you're in college, you'll probably understand C or C++. This is a very simple code. On line 4 I've included a passwords.h. That passwords.h contains a list of passwords that I won't show here, obviously. Let's assume this program is running on a network such that anybody on the network can interact with this program. This basically functions like an SSH program. You give it your ID, so ID will be a numerical number. Then it will take your password. If those are correct, you would get a shell on the system so that you can execute commands. Or if not, you can execute, or you can just basically, you can't log in and you should not be able to log in. So that's basically the gist of the program. It's a very trivial SSH, and it is only the size that much that I can show on the screen and people don't get out of context. So I'll want you guys to read through this, see if there's any problem with this code. So if there is, please post those on the chat. And I would like to see how many of you are there. Like how many of you understand this. I'll give it a couple of minutes. Let's see. I'll monitor the chat in the meanwhile. Yep. All right, if you want, you guys can take a screenshot and work on it. I'll move Palo in the chat. You can also discuss this with me after the talk on whatever channels you wanna prefer. So we have one bash injection. That's all right. So yeah, so basically this program has a vulnerability, and as part of vulnerability research, it's our job to figure out the vulnerability. So that's basically what vulnerability research is: to find out vulnerabilities in pieces of code, not just in code but also in systems. So people have found out vulnerabilities in the hardware, in the Intel CPU itself. Other than this, the design of the system, or how different pieces are coupled up, such as, let's say you have an authentication mechanism, a service that authenticates users, and there are services that lets the user interact with the data stored in the DB. So if there's a problem with the config that these services are talking with each other, there might be a vulnerability there. So a vulnerability is not specific to code. It can be inside the system, the hardware, the configuration, the setup, the environment itself. All of these things combined. So that's what basically vulnerability research is. Even in terms of locks, so you would probably see many people picking locks on YouTube if you want to search that. So they're also termed as vulnerabilities. So as a vulnerability researcher, it's your job to pick out a target. In this case, I am asking you, since most of you understand this program in C, whatever this I asked you to find out vulnerabilities in this piece of code. Now, what is an exploit? So, exploit is a set of steps that interacts with the vulnerable system and takes advantage of the vulnerability. So, eventually, the exploit would make the system do something which is not assumed, or which is not probably visioned by the people who build that system. So, something out of the ordinary. So, let's say in this program, there are only two states. So, the two states are: the first state is you have a username, or you have an ID and a password. You log in, you get shell. That is like one authenticated set. Second is you have you don't have a login and password, and that's invalid login state. So those are basically the two states. Other than this, if you are able to make this system go to a third state, which is not either one of those, that means either the person who is trying to interact with the system doesn't have an ID or doesn't have a password, and even then they are able to uh, run a command on the system. Or even though the person has a username and password, but you make the system behave in a way that they are not able to log in. So the first case would be an exploit called code execution, so remote code executions, in which without having the username ID you are able to run commands on the system. The second case would be a denial of service. Even the legitimate user who is not who should be able to have access to the system, you are not letting them. So that's basically what exploits are: how you achieve those things such that the system behaves in the unintended way. That's basically an exploit. So in terms of vulnerability research, the first task, or uh, mostly the all of the task, is to find out the vulnerability and then probably write an exploit. So there are clear differences between a vulnerability and an exploit, and it is very important that you know it from the get go. So some people only find vulnerabilities, they don't write exploits. Some people, they depend on other people to look at the vulnerabilities, and they write the exploits themselves. So to write the exploit, you need different sort of knowledge. To find out the vulnerability, you have a different sort of mindset in which you try to crack the code basically. So now this is basically the exploit. Let me just open. Okay, this is basically the exploit for this code that I showed you. So in this case, this code takes an integer that is probably your ID, and then it takes in your password, which might not be greater than 100 bytes, and then it compares the saved list of passwords with the ID that you have given. So now I know how to attack this system. So I've written an exploit that basically gives me the privileges of root without uh, like me putting in my password. So as you can see, uh, that is here. First we give in the ID. So instead of a number, I have given -2, which basically passes this check. How is up to you. So this is basically called an exploit. So this exploit involved two steps. First is gave a number that the system doesn't expect, it bypassed the limitations that the system was trying to put in about some input value. Then I gave it some input which satisfied some other criteria such that it is able to let me execute some commands onto the system. So in this case, I can run arbitrary commands and it will give me basically the whatever command output I am trying. So right now I have compromised the system basically. So if you like doing this, or if you like the sound of me doing it, this probably would excite you, like how to find a vulnerability, how to exploit it, how to understand the systems involved. Such as I gave you an example of an elevator. So in this case, the system might be that elevator has a couple of has some it goes to some floors. On each floor there's a control board which asks the elevator to go up or down. Inside, somewhere at the top, there might be a computer that is making the decisions of when to stop that elevator, when to start it, when to wait for some people, open the door, close the door, look at the target, or if the input is within bounds and stuff like that. So if you are able to understand this system, understand the things that build that system. So basically, it could be a Raspberry Pi as the main driving computer, just an example. It could be an Arduino. There could be input from some I2C devices, or some direct interrupts, or direct change in voltages based on the buttons that you press. So you need to understand the system that basically builds all of it. So once you have that knowledge, if you try to do that, you'll basically get better at it. So if you like the sound of it, I'm going to continue. So in vulnerability research, we try to find out weird state. So as I said, in this code there are some states that are envisioned by the people who wrote this program. For example, I wrote it, I knew that I'm writing it for a bug, but sometimes people make mistakes and they introduce the bug without planning. So in this case, let's say I was the code author. I was writing something, I was writing a service basically that interacted with the network. So anybody on the network should be able to kind of SSH to the endpoint where this service is running, and they should be able to put in their ID and passwords, as that then they will be able to run some code on the machine. So like a normal SSH thing. So I had a start state. So I had a start state such that the user will connect. Then there are some predefined states. That means the user will input username, password, and they will be logged in. Then there's a weird state. So weird state is something when the people who wrote that code, they didn't expect it. And that's basically all about what we do in vulnerability research. We try to break the assumptions such that the program goes to a state which is a bit weird than what you would expect it to be in. For example, in case of elevator, you could make the elevator go to the top floor where there's no door, for example. Like, that's just a case. I don't know how elevators work, sorry. Yeah. So as a student, I when I was in college, I like to do this. I like to find out vulnerabilities in like such vulnerabilities in code. I like to do stuff like this. I would like to break into systems. I like to look at different softwares. I like to see how they work, if they have any bug present that I can exploit. Such as, for example, there's Moodle is an open source portal where you can submit your submissions for assignments that you can give in tests. Now if you find a bug in the system, find a vulnerability in the system such that you're able to look at other submission, or you are able to bypass a quiz, give yourself arbitrary numbers. Now those are the outcomes that I was very excited with. So I used to pick up softwares that I see around me, and then I used to look at them. If they are open sourced, I used to look at the code that they have, and I used to basically install and run them, see how they behave. So as a student, what is the sorry about that. Yeah, so as a student, to eventually get to that goal, this is the path that I usually envision for others. So I mentor a lot of students who are currently in college or in school, and they are into infosec. So this is what I usually tell them. So as a student, you should play, from student you should go to playing CTFs. So CTFs are basically, I'll tell you about in a bit. CTFs are basically hacking competitions. Then once you are into CTFs, you will likely be solving challenges such as these. So this is a very simple CTF challenge. I doubt any CTF will keep them right now because it is too easy even for a student who is like 1 month into vulnerability research. Then there would be some coordinated disclosures such that you will find vulnerabilities in random software such as I said, Moodle or whatever else. And then the final stage that you'll keep going between these, you can keep playing CTFs to up your game, basically build some skill, and you'll keep working in parallel to find out vulnerabilities in different softwares. And then final stage or the best case is you go to pwn to own. So pwn to own is a hacking competition which is probably the god tier hacking competition that we have. In this competition, pwn to own, you can google it, you can watch videos of it on YouTube. uh, Vendors such as Microsoft, Apple, they keep their updated devices so that there's everything is patched. There are all the prevention mechanisms present on the device. They keep it open on the desk. Somebody or the attackers, they come in, they try to exploit that fully patched device. So that's basically prone to own. So that means people who are going there, they are the top tier hackers of the current time. It's quite adventurous when you watch it, like what did people do, how did they get code execution on this machine, how do they compromise it. So the phone to one basically means you hack it, you own it. So that means if I hack a MacBook on that platform, they basically give you the MacBook and a lot of, somewhere in terms of 50 100,000 dollars for each attack that you make or any device that you compromise. So it's definitely a very well paid industry in this case, right? So I'll tell you a bit about CTFs. So CTFs are basically hacking contests. In this hacking contest, there might be a website, there might be a binary, some crypto system, there might be some forensic stuff going on. So you'll have to attack a website or a binary. You'll have to analyze the crypto system and find weaknesses in the maths, maybe maths or implementation of the crypto system itself. Or you should be able to analyze a disk. Let's say a machine was compromised and the attacker ran some commands on that drive and exfiltrated some data out of it. So you might be having that image of the drive so that you are able to see what attacker does. So depending on what you like, CTFs will probably give you the most exposure to infosec industry, because these problems are related to infosec. Now, one thing that's definitely help you in vulnerability research is the binary part. So in the binary part, you usually have two types of challenges. First is pwning, second is reverse engineering. So reverse engineering is something that if you have a binary, let's say if you have this program and it's compiled and it's given to you as the ELF or EXE, uh, and then you basically, since you have that binary itself, you don't have this code. It's the task of figuring out what that binary does, how does it interact with different components. And then pwning is when you find out the vulnerability in that binary and then you write an exploit, in the case that I showed you earlier, like this. As part of the pwning and reverse engineering process, you would get binaries instead of source codes. In pwning you can also get the source code, that's not an issue. But the eventual task is to find up that exploit that gives you code execution on that device where that binary is running. Now, if you want to look at more CTFs or how they are done, you can go to ctftime.org. It is like a calendar of CTFs, people who conduct very good CTFs, top tier CTFs, CTFs which run in the top tier infosec conferences such as DEFCON or Black Hat. You can see the CTFs listed on there, and other than that, almost every weekend, people who play CTFs run CTFs for others. There are multiple companies, multiple CTF teams, even education institutions such as yourself. You guys run CTFs, they register it on CTF time. So if you're into that, you can go there, you can look at challenges, you can look at past CTFs, you can look at write ups of different challenges, such that what happened in the past, how do you solve those challenges, and what are the technologies that are involved, what are the tools and techniques that you can use. So that's how I basically got better at it. When I was in college, I my goal was to be a hacker, because as soon as I got out of school, I wanted to be a hacker, or even in school I wanted to be a hacker. I did not know how to be there, but I wanted to be a hacker. So in college, I asked a couple of my seniors like what to do. They told me a couple of points like go into ethical hacking, go do this, look at this video, understand this. but that doesn't give you a credibility in front of people who are actually gonna hire you for being a hacker. So unless you do or you break some actual stuff, people are not gonna give you respect. So you'll have to prove your credibility. A certification is definitely one of that, but me being a poor college student doesn't make me get certificates that easily. They're usually very expensive, or they would require dedicated time other than the course that I was already following along in college. So jokes, I never followed. So yeah, so basically the gist is CTF time. You get on there, you register your team, try to play as many CTFs as you can, try to solve from the easiest challenges. See, if you're not able to solve a challenge after the CTF, somebody or someone will post that write up on CTF time. Or if you're connected, or if you're discussing these challenges with other like-minded people who are solving that CTF, there might be a Discord or a Slack, you can discuss it there. And that's how you basically get better at it. First day you won't understand what the challenge meant. Next time you would read about the challenge write-ups and you would understand what it meant. You'll probably, the next time that you see similar challenge, you'll at least do something that would give you some better outcome. And this is how you basically go up the ladder and build your skills. And that's how I did it. It is a constant loop of attacking or hacking the challenge, and then reading how other people did it. So that will give you a more perspective of what the people who are actually solving these challenges, what their mindset are, how are hard challenges solved. So I won't even consider myself the best, or even I would say I'm a medium CTF player. I sometimes I can on good days I can solve the hardest challenges, but not every day. So I'm still working on that now. So that's basically how do you, as a student, how do you get into vulnerability research. Now I'll get back to the core concept of what vulnerability research is, and how to be better at it, or if you want to get into it, how does it look like as a vulnerability researcher. So, in vulnerability research, we analyze a system. It might be a hardware, software, some protocol, or the implementation. Let's say implementation of a crypto system or the implementation of a protocol. For example, protocols such as we are using this platform. I don't know what it's called. I forgot. Sorry. Yeah, StreamYard. So, for example, StreamYard, it might have some protocol to talk to the people, such as you participants. There might be a protocol to talk to me. I'm presenting something. So if this was not a website, this was some common software, you'll need to understand the protocol of how things are happening. What is the protocol? It is network protocol it is using to take data from my end, then it broadcasts it to all of you viewers. So you need to understand the implementation on how it was done. What are different systems involved? Is there a server present at this location which is collecting data from all of you such that you are online? It is posting it back to me so that I can look it in the chat, and similar stuff like that. What is the stack of this website? Like, is it written in Go? Is it written in Node? What are the popular softwares that do some such kind of things? So it might be, there might be some open source competitors to the same thing. So for example, there might be Zoom. uh, Similar to Zoom, you might have some open source competitors as well. So it's basically analyze the whole system and the surrounding environment, analyze the problem that the system is trying to solve. In this case, this is a streaming website. The problem that the website is trying to solve is how to be simple at managing conferences or talks or stuff like that, right? So you analyze the system, you see what are the smaller parts involved in the system, what is critical to the system, such that it is the bare basic minimum that builds up the system. The next step is to locate and analyze the vulnerability. So that means locate is a very big point. It basically, it could take you from 5 minutes to an year or a couple of years. So I have heard people talk that it took them an year to analyze or to locate a vulnerability in a software, for some pieces of software, for example. So that is basically where the attacker mindset comes into picture, the code breaking mindset of, or looking looking the problem as a puzzle. How do you take out smaller pieces of the puzzle, solve it in different space, and then put it back? So it's basically totally up to you on how you want to solve that. I'll post some ideas in a bit, but we'll see. Now the last part of that is to exploit it. Now if you found out a vulnerability in this website that we are currently using, if you find out that even though you are not a presenter, you are just an attendee, you are still able to unmute yourself or speak or present something or basically stop the presentation that somebody else is giving, that is basically the outcome of this vulnerability research is what there. um, yep. So next thing is skills. So what are the skills required or the mindset required to do this kind of job? So first thing is implementation setting. So in this case, as I said, this is a website. So this website was written in a specific language, so you probably should have the understanding of that language. For example, let's say the website's front end is written in React, for example. You should understand, although front end doesn't matter to hackers that much, but there are some injection vulnerabilities that you do, code injection attacks such as XSS or stuff like that. So you need to understand the language or the pieces that build the system. So in this case, it's a website, you should understand the React for front end. Similarly, at back end, this website might be using Python, this might be using Go. So if you understand how things are built in that language, it gets you a step closer to the actual analysis of the system. So if you know that this website was built in Go, you would probably do the usual attacks or find out the usual vulnerabilities that people make mistakes in terms of writing code in Go, for example. Next thing is understanding the config. So now if you're understanding the system, you should understand what part of the systems are configurable, what part is given, or what part is controlled by the user input. Can user change something which eventually drives to change the config? For example, Hasham can basically change the setting of this meeting such that anybody can do anything or something like that. So understanding parts of the configuration, the languages that built up the system, the environment. For example, this services might be deployed on AWS. So if you understand how AWS works, or how are different services deployed in AWS, what are access mechanisms, how do you get a token, how is data saved into some of the buckets, how do you get the data? So uh, it basically needs a lot of knowledge about the environment around the target itself. So that means the field of vulnerability research has a very steep learning curve if you pick up a very hard target. So for example, this was a very simple target, I gave you the code. So only thing that you need to understand is that this is written in C. So you need to understand C, you need to understand what are different vulnerability patterns in C. For example, here, the id is an integer, however the verify id takes an unsigned integer. So casting a signed integer to unsigned or unsigned to signed, it might be something that you probably haven't thought of. So this could be a vulnerability pattern. So these are the things that you'll probably need about the system. Next thing, how is the system interacting with user input? So in this case, I gave it an input, first as an integer, then as a string. So first integer was used to go as an index into an array. Second integer was used to compare that array string to the input that I gave. So this is also an important knowledge. Now once you have done that, you'll probably get code execution and it does not matter at that point. So so that's basically what you should understand about system. So this was a very small target. This is what, 10-20 lines of meaningful code, not more than that, I would say. Yeah, let's say 20 lines, or maybe 10. So 1 2 3 4 5 6 7 8, yeah, basically 8 9 lines of code. Other than that, so in this in this frame, the target is very small. The learning curve is pretty, you can say it's almost flat. You just need to understand C and related vulnerability patterns in C. So if you're a student and you want to go into vulnerability research, you should probably start with smaller targets. You should be able to write toy programs such as these, find out the vulnerability, or look at others people programs. In this case, CTFs are a very good, you can say, experience for them, because in CTFs you have different level of difficulties for each types of challenges. So as in this case, this might be a pwning challenge. Pwning is PWNING. We usually pronounce it pwn. You can also call it pawning. So pawning challenges, they usually have increasing level of difficulty. So it might be a 100-point challenge, then 200, 300, 400, 500. So as a student, you can start from picking up the 100-point challenges, looking at what the vulnerability is. Eventually, when you spend some time, a couple of months, let's say 3 4 months, half of an year, you'll probably get to that point that you are able to solve those 100-point challenges, and you are able to understand how this system was vulnerable, and probably write an exploit, right? So in this case, if you take this problem as a puzzle or a code breaking exercise, so it might be your mindset. That's basically what my mindset is. I like to solve puzzles, so I see these things as puzzles, and I try to solve them as puzzles, like that. Other than this, some people like breaking code, some people understand how a code can be vulnerable, and they basically build up that skill more and more. They keep sharpening that their code breaking knife, unless they find out the point where they have to use it. So those are the skills that you'll probably be needing if you're going into this field. And I won't say that you'll need it from the get go, but if you're motivated enough, you can build these skills within a time frame of, while what 4 years in college, or let's say you're in second year and you still have 2 years to go uh, before you go into it professionally. So as a student, why do this if it is not leading you to a job? So most people, they're in college only to get a job. That was me, for example. So first thing is, you could definitely freelance. There are bug bounty hunting websites where you can register. They give you a safe place where you can find out these vulnerabilities and exploit them. You can definitely do that. You can do that on your own time. So it's basically freelancing. Nobody has an end day that, okay, you'll have to find this exploit in next 3 days or you are out, and stuff like that. Other thing is the gray market. So there are a couple of markets regarding vulnerability as well. First thing is your white hat market, in which you find out the vulnerability, submit it to the actual vendor. So such as, if you find out the vulnerability in Google Chrome, you submit the vulnerability to Google security team, and they will handle, they'll fix it, and they'll give you some reward. So that's basically what you get as in terms of job. Other than this, there are also gray markets, such as people who are from antivirus companies, or people who are defenders, such as CrowdStrike itself, but we don't do that. So there are companies that will take exploits out of your hands. They will look at the exploit, they will understand how you made that exploit, and they will build protection systems that would stop similar exploits that an attacker is going to use to do the same thing. So similarly, they are called usually gray market. If you are into actual black hat, you could go full black hat market as well. You can sell these exploits to bad actors who will use this to compromise actual good people. Now there are also jobs in antivirus companies. So I have written like us, like CrowdStrike, but CrowdStrike is not an antivirus company. But we have a lot of competitors who also do the same. So so since I am doing it, I am a vulnerability analyst at CrowdStrike. Similar to me, there are multiple people in different teams who help other engineers understand what a vulnerability and what are exploits, so that the product that we eventually have, so our task is to stop breaches. We don't let somebody get into your system. So how do we do that? We'll need to understand how people who get into your system, how do they function, what are the tools that they use. So zero day exploits are one of those tools. So we'll need to understand, to stop them, we'll need to understand what does an exploit look like, what are vulnerable softwares, how are they compromised, how are actual vulnerability researchers or actual black hat people who are going to attack your system, how will they write that exploit. So we'll need to let the developer know, understand the problem, get them a potential solution such that they can code and they can prevent it from the system. So that's why other antivirus companies, even our competitors, look for people in vulnerability research, so that they are able to build systems that can stop the other offensive side of vulnerability research from getting into your machines. Next thing is product companies. So by product companies, I mean the people who write code, such as Microsoft. They build a lot of software. They build Windows. In Windows, there are multiple. So Windows is a complete operating system. So it might be that there are vulnerabilities that an attacker can talk to the Windows server deployed on the network, and then they can compromise it. There are different implementations of protocols on that Microsoft machine. So there might be some DLLs. There might be the kernel itself. So as Microsoft or the people who wrote that software, they might not be that good at finding vulnerabilities in that software. So it's not always that a good software developer is a good vulnerability researcher, or even a good vulnerability researcher is a good software developer. Neither of them is the case. It could be for some people, but it is mostly not. There's a very different kind of mindset for being a software developer and being a people who break those systems. So people such as Microsoft, Google, and companies like that who write actual pieces of, even Apple. So even they would want people with that mindset, such that before they ship this system to end users, they fix those vulnerabilities inside the organization itself. Because if your product has more and more vulnerabilities, lesser and lesser people will start adopting it, or you can say more and more people would stop adopting it. So if you knew that Chrome on Android has a lot of vulnerabilities, and if you use it, most people will compromise you almost daily, you wouldn't probably use it. So to build or to get more market share, you need to get more and more, you can say, software which is not broken. For example, Internet Explorer, it's still very broken. There are a lot of vulnerabilities, so Microsoft eventually phased it out. So they phased it out in focus of Edge, for example. Similarly, there are research based companies as well. So there are companies who do vulnerability research full time. So that was one of the role that I did at my past company. I used to do this full time. By that I mean I used to find out vulnerabilities in new softwares almost every month. So there are companies around that. Last part is academia. Now if you want to go for an MS, there are different universities across the world which have dedicated cybersecurity programs. So you could go there as a PhD, you could go there as an master student, and you could enroll into their cybersecurity program, which finds out vulnerabilities. You could talk to the professors and get into them as well. So those are the motivations for you to get jobs or to get, let's say, further studies, right? So let's talk about the vulnerability research process itself. I just look at the time. We are very close. Okay. So let's talk about the process itself. I'll try to boil it down because it could get very technical. You can hit me up later. Now, first thing is you choose a target. So what choosing a target means, you choose the system that you'll be breaking. So as I mentioned, elevator in your building. So if you choose that target, so that is basic. If you choose it, that's basically the target. That means you are choosing to target that elevator. You are trying to break into that elevator system, right? Similarly, for example, in my past work experiences, I have chosen targets such as the Google Chrome browser itself, Firefox browser, Adobe PDF reader, so software that you normally use. So how do you choose a target is, start with something you understand. So for example, you definitely understand how elevators work. So for now, so start with something you understand. So if you understand a system such that you are normally using it, it's some part of the problem you have already solved, is how to interact with the system, where are user inputs given, stuff like that. Or things that you actually use, the browser that you're currently using to look at this talk, the Linux kernel, for example, which you might be a Linux user, or in case such as if you're using Windows or Mac OS or whatever, even your Android devices, that's also Linux. So if you use it, you'll probably be knowing more about the functions and features of the software that you're using. For example, if I use Google Chrome, I know you can render like you can look at websites with this browser. The website can have JavaScript, it can also have a video frame or stuff like that. So you know where the inputs coming into the system are from. Now you can also be a new recent crazy bug someone else found. So if you're a vulnerability researcher, you interact with other similar minded people, maybe most of the security industry is on Twitter, so you can follow the top people and you can see what they are actually doing. So they post that this month I found out this CVE in this product which has been patched in this last month, for example. So uh, based on that, you could also pick up the same target. You could look at what they did, you could replicate what they are trying to do, and in this process of replication you could also land a vulnerability of your own. So next thing that we do is we find out the attack surface. By attack surface we mean we locate the points of weaknesses in the system, or we locate where there could be a potential weakness. So the whole surface, for example, we should know what is the input process and output flow. So in case of Chrome, the input is that you put in the website in the bar. Then there's another input that Chrome browser will, okay, I have misspelled surface, I just saw that. Yeah, so in Chrome browser you put in the URL, Chrome will take the input from the remote endpoint, it will browse to that website, get that JavaScript, HTML, CSS, whatever as input, then it would process it. By process I mean it would render the same thing. So here this is serving from a hackmd.io website. This is basically a small text based slide, so there are some HTML components, some CSS components. Chrome will analyze that, it will see how to render this to the display. So that is basically the process, and what is the output is that you basically get on the display some rendered website. Now what are the possible input types? So the input types in this space is the user input in terms of website there. Sometimes you also build websites, so that is also an input, because this Chrome browser will take that data and render it to the screen. So that is also kind of input. So it could be HTML, CSS, JS, and as I said, this website that we are using to stream this talk, so it could be video input as well. Now you do some market research. So uh, m- products which have a large share of the market, for example, most people, I'm just saying that as an opinion, most people prefer to use Chrome, most companies prefer using Chrome. So on their employee devices, or even you in your in your Android or iOS devices, you might have Safari or Chrome. So I would say that Firefox has a lesser market share in terms of usage. So as a good attacker, or as a person who wants to find out vulnerabilities with more impact, we prefer products that have a larger market share, for example, because that would give us more bang for the buck in terms of writing or finding out a vulnerability. So if I say I find out a vulnerability in Chrome, it would probably be present in about, let's say, 1 billion devices, just an example. It could be present on 1 billion devices, so that sounds crazy. That means potentially I would be able to compromise a billion of the devices on this earth, on this planet. Or maybe if it is running on International Space Station, I would be able to compromise that as well. So that's just an example. So we do some market research, we find out the good targets that is present almost every in the industry, and then the as large part is variants. So what variants mean, I mean is, so before you start doing this stuff, many people have already done it in the past. So vulnerability research is not something new. People have been doing and are constantly doing it in parallel. If you pick up this, so people have been finding out vulnerabilities in Chrome, let's say from 2004, just an example, in Internet Explorer at least. So so there are vulnerabilities that might be very similar to that piece, that pattern of vulnerability. So if I am a software developer, and if I don't understand, or if I make some assumptions about the language, so in this case I made an assumption that if I cast my or pass my integer id parameter to verify id which is unsigned, it does not have a side effect. So I assume that. So if I do similar code, if I have a large project such as, let's say, Linux kernel or the Chrome browser, and I didn't understand that this is a problem, and I kept committing the same problem to the code base again and again, so there's a pattern that you can find within the code that I wrote. So if you look at the Git history and you saw commits made by Sudhakar, you would see that some of them have the same pattern where I cast into unsigned int in terms when I call a function or something like that. So this could be a vulnerability pattern, which one of which, let's say, I found out, you found out this is a vulnerability and you reported it and stuff like that. Now if you could understand that this was a pattern, you could also find out similar vulnerabilities. So this is what we call a variant analysis. So the code might be structured in a pattern that is basically vulnerable, or the system might be designed in different pieces which could be in that vulnerable pattern. So we'll need to analyze the system and all the all the past vulnerabilities, and how can they form a pattern to get more potential new vulnerabilities. So this is probably a very time consuming task, and it is involving a lot of, you can say, background research and stuff like that. Now other thing, in attack surface, how things work, as I mentioned this a couple of times already. You should understand how the system is built, what are the code components involved, uh, what are the protocols that we are trying to implement, what are the inputs and stuff like that. Now you should understand this very well to finally get to the point where we find out the attack vector. So by attack vector, how do you find out attack vector is, you need to understand what vulnerability classes are. I won't go into individual ones, we are already short on time now. Yeah, so you need to understand basically the choice of language or the target that you picked up, the language in that in which the target was written. It could be, if it is based out of some web technologies, there are some specific vulnerability patterns or vulnerability types that you'll need to understand. Similarly, if it was written in C or C++ in terms of such as here, this could have a memory corruption vulnerability class, in which it could be a buffer overflow. There might be an arithmetic problem, such as which was here, and stuff like that. Now once you understand, so this is very deeply technical. You could go ahead, Google, you could learn, look at OWASP top 10 vulnerabilities, figure them out, and then basically move. Then you should understand what chaining primitives look like. So for example, in your code you might be adding, subtracting something from a pointer, and that could eventually lead to additional issues within the code, such as heap overflow. So you should also understand how are exploit systems built, how are different vulnerabilities chained together with each other to get more juicy or better primitive inside the system. For example, in terms of elevator, if you found out that if you press the both up and down button together, for example, you could stop the elevator at one point. So that is just an example. Now, the last thing that I would like to mention is, you should probably also understand code review. Most of the softwares that people attack, such as Google Chrome, is built on an open source Google Chromium. So you can clone Google Chromium on your disk, and you can look at the code. If you understand how C++ systems are written, you could review the code. If you know, or if you know that you are a better person, better than normal software developers at finding out vulnerabilities or stuff like that, you can review the individual pull requests or individual changes made to the code, and then figure out whether it is a vulnerability or not. So this is a very large skill. Even nobody is perfect at it. They usually learn with time. So as you get better at understanding the nuances of a language, you'll be a better code reviewer time through the time. The last part is reverse engineering. As I said, Microsoft operating system is not is one of the hot targets, because most people use it. Now it is not open source. There are a lot of systems, or everything inside it is mostly closed source. It is in terms of binaries. The kernel itself is an exe, or the Chrome browser or whatever Edge browser is also an exe. Other than that, whatever you use, it's mostly an executable. So you'll probably need to figure out to understand what that exe file is doing. So for that, you need to reverse engineer that file, understand how it is functioning, what are the inputs and stuff like that. So that is also, these two skills are very much highly technical, and you'll need to build them from scratch if you are going to do this. Last part is fuzzing. So fuzzing is just running the software millions of times with different types of inputs, and looking at the behavior such that it will do something out of the ordinary and go into that weird state that we talked about some point back. So in fuzzing, we what we usually do is, we give it some random inputs. We look at the behavior of the software. If it is something that we don't expect, we find why is it, how did we reach that state, and then we try to find out the vulnerability. Now that's pretty much it. There are some tools and techniques. It totally depends on you. Some good tools that I would definitely like to mention is one good code IDE. For example, if you prefer VS Code, whatever. If you prefer Vim, I prefer Vim with C tags enabled. So you need a good code IDE such that it lets you browse around the code. You need a good debugger that lets you debug the actual software when you are running it. You also need some other pieces such as if in reverse engineering you'll probably need a disassembler, decompiler, and stuff like that. So that is a very technical topic and I wouldn't want to go there at this point, but if you're interested you can always talk to me. So thank you for following me. We are right on time. You can find me on these right now. You can also mention or you can add me on Discord. I'll be able to answer. Yeah, that's pretty much it. I'll be looking at the chat if I have any questions. Okay. Wanted to
Hello,
ask.
hello.
Yep. So I'll
Yeah.
I'll go through these messages and try to answer. Let's see.
Sudhakar, actually, we are going to display these questions for you. We've already made a list of all the questions that have come in. So I think you can see the screen now. You can answer one of these questions. Members will be putting them on the screen.
Okay. How can one get into security after spending the initial years as an SCE? So as a software developer, you'll probably be privy to the nuances of the language itself. So you could start by reviewing the code bases that you have written in the past. It will probably have those vulnerabilities as well. Or you could go ahead and look at what others write. So you could do active PR review and stuff like that, such that you understand or you find out vulnerabilities. So eventually you could talk to your manager and change to an infosec role such that you are able to review all of the code that the organization is producing. For example, at Amazon, there used to be a dedicated infosec team, which, if you are going to write a service that is interacting with customer systems or popular endpoints or other endpoints which involve those systems, you'll need to get it to review 4 or 5 times at least. So first time when you write empty classes, so that's basically the design review. After that, when you write some sort of code, you'll be going through circles, getting to and fro between the review team itself. So you could switch to an infosec team. So those roles are usually called security engineers. They do a lot of code reviews. So you can do that, definitely do that. And while doing that, you can also dabble on your own time, playing CTFs or looking into other ways how security is built inside the organization itself. So what I would recommend is you first switch. Once you are in a software developer role, you can switch to other roles inside the organization. And most of the time, it's about 1.5 years. So if you're interested, you can switch to an infosec based role, get better at it, and then switch to a completely dedicated infosec company if you want. Right?
Right, right. The next question will be coming up.
Yes. So the number of people in security research is less in India. Yes, it's very less because we don't prioritize it much often. I would say it's very less because when I was trying to get hired as a as a vulnerability researcher out of college, the number of job postings that I found out was very little. You could say I could count it on one hand. So that's less than five. So that's why. So but if there's a market that is inside, or basically since there's not a market in India, most companies such as the antivirus vendors themselves, they would hire outside from India. So if there's a you can say talent pool inside India, why would they not? And that's basically is the direction we are going right now. So right now more and more people are hiring vulnerability researchers in India. Yep.
Right, right, right. Okay,
India has one of the largest number of people in cyber. Yeah, so that is a pretty good question. So I would say most people so it's because this would be controversial, but labor in India is cheap, and most of the type of security companies that I have seen in the past are mostly focused toward penetration testing and vulnerability analysis. So it's called PTVA. domain where they break into networks which the customer gives to them. So the customer might give you a website and ask you to break into it or find vulnerabilities in it. So that is most of the like that is the most common job role in terms of security industry in India. So there are a lot of companies that do penetration testing. There are government associated programs that let certify those companies, and they'll have to do some government projects as well. So I wouldn't say the awareness about domain is very low, because it basically, you as a student, it depends on the environment that you are brought up in. So in my college, I cultivated a very good security scene. Similarly, in parallel, I know people about IIT Roorkee, Guwahati, Bombay, and Delhi as well. They had a good CTF culture, and that's why people were more into cybersecurity. Similarly, there's a university called Amrita University, and they have a very great cybersecurity culture. So students there know that there are good cybersecurity companies which they can get into. So it's basically more about, in terms of students, if their seniors or alumni are already doing some stuff in cybersecurity, for example.
Right, right, right. Okay. The next question. Okay. So she says, do you think the reliance on the internet and remote tech for basically all professions now is opening up a new window of vulnerability for social engineering attacks? What do you think?
Yep. So let's say pre-COVID times, most people are based out of office, so they went to the office. Most companies have a dedicated, let's say, IDS, IPS at the endpoint where all the traffic is coming from the internet and it goes into the office environment. So you have only one point where the attacker will probably attack, or the traffic will eventually flow through. So you can stop or you can put in measures on that point, and that was very easy to defend. Now everybody's working from home. You have like millions of points that the attacker can attack. So that's basically what we do at CrowdStrike. So as more people go into remote working and they work from home, there are potentially more and more modes of uh, ways that attacker can probably use. So that is probably true. And yeah.
Right, right. Okay, okay. All right. There are. I mean, we have a lot of audience on YouTube, and we have a lot of questions. So yeah, this is the question. Another question.
Guessing that most vulnerabilities require specific environments to work, and most online platforms that provide that for practice are really expensive. Are there any alternatives? Yes. So I'm guessing that most vulnerabilities require specific environments to work. So that's not the case. So see, doing something in vulnerability research, it needs a mindset, and that mindset can be cultivated by doing this exercise regularly on smaller targets. So there are CTFs and there are war games. So war games are websites such as rootme.org, where you could find a list of 20 different challenges, for example, which will be for you. So you download that binary, it will be running somewhere in the network, you interact with the binary and you compromise it. So there are multiple websites that do it for free. So you could go to rootme.org, you could go to pwnable.tw, pwnable.kr. There are multiple sites. So as I said, if you hit me up on Twitter, if you are interested, we can definitely talk, Discord, whatever you want.
Right, right. Okay. Um, the next question will be coming up. Yes, that's the question.
Okay, so wanted to ask, what's the most stupidest vulnerabilities found in a large user base production app? Yes, so the stupidest one would be, as part of some analysis or some forensic stuff I was doing post breach, I found out the person who wrote the code for an authentication service in a popular, let's say, X app. When the users reset their password, so after, let's say, 6 months, the password would usually reset. The system would ask the user to reset their password, or the user would willingly reset their password. The production code had a log there such that it would log your old password and the new password in plain text, and anybody who has access to the logs could look at your old password and the new password as well. So that's probably the stupidest one that I've seen.
Okay, all right. That is yeah. So, are there any security startups that you find commendable and would like to mention?
um yeah, there are a few. So there's a couple of So I wouldn't want to make it public. It's a bit controversial, but you can definitely hit me up after. I would not answer that. Sorry.
Okay, all right. We can move on to the next question then. So this is, I guess, from one of the first years. How does a beginner with no experience gain experience in this domain apart from CTS without doing
So
illegal stuff?
yeah, so there are you can say courses on that. So there's a course called OSCP. It's totally legit, and it is probably the best you can say intro level certification that you can do. So you can definitely Google it. OSCP is part of the offensive security course, and it's probably the entry level course that you can take. It's about six, 700, $800, and then $100 for the examination fee. So other than CTFs, you could the main thing is that you need to make yourself credible. When HR sees your CV, they should know that you're into security, not just by looking at what you mentioned about you in the CV. There should be some public you can say record of what you have done. So a certification gives you a certification number which can be verified by the HR people, so that definitely gives you some credibility. Other than that, you can publish a blog that is visible. You can make yourself visible on Twitter. You can do random crazy stuff and post it on Twitter onto a blog too. If you amass a large number of followers, or if you do something, or if you do something out of the blue that nobody else has done, that will probably give you that credibility as well.
Right, right. Okay, okay. The next question would be coming up. Okay, this is a question that has come up
Yeah,
in my
so
mind as well.
so so finding vulnerabilities is common. So as I said, people write code thinking about something else, but people who broke that code, they think about something else. So not all, both of these set of people, they don't have the same mindset. So every software will have vulnerabilities. It's up to the people who build those softwares on how to mitigate them. So there might be vulnerable code patterns present, but there might be some mitigation. For example, uh, the operating system might be built in a way such that attacks don't work, or even if you compromise Chrome, you are not able to compromise the whole operating system, for example. So it's very common to have vulnerabilities. Now 8 is not a legit number. Even just in last month, in November patch Tuesday, we saw 55 vulnerabilities, which was very, I think, or 45, I think, which was lesser than average of the whole year. So around 70 vulnerabilities per year are patched by Microsoft, per month are patched by Microsoft. So in this year, this could be about, let's say, 7 and 800 already. So yeah, it's very common.
Right, right. Okay.
Yeah, you can definitely go to HackerOne. HackerOne is a good bug bounty program which you can join, and you can look at the targets. There are others as well. I've never done bug bounty hunting myself, but a lot of my friends have. So I can't recommend anyone. The only one that I remember, because I have a T-shirt from them, is HackerOne.
Right, right. Okay, okay. The next question would be coming up. Major
So
programming languages.
yep. So if you're trying to break softwares such as websites, you probably need to understand softwares that build websites. So Node, Python, Go, JavaScript, whatever. So that, other than that, if you're trying to break into operating systems or such as Google Chrome, these are probably written in C or C++. You'll probably need to understand that, and assembly as well, because everything gets compiled to the binary. So
Right, right. Okay.
there is no major language that I would say that you need to master, but if you choose a target, or if you like a specific type of products that you like to break, you need to understand that ecosystem.
Right, right. Okay. This is a question. Have you ever dived into more gray or black hat areas yourself?
So I know people who have done carding, but I don't know what duping is. But so I've been doing this since, I would say, 2011, and I've definitely known people from Facebook or other channels where people were actually doing carding. So carding is an illegal activity where you purchase credit card or stolen credit card from some website, some shady website on dark web or something, and then you use it to buy stuff on your own. So I've definitely known people who have done it, but I don't like to associate with them. I don't like this kind of activity, so I don't talk to them that often, but I definitely know that they've done it, and they've gone to
Right.
jail as well. So I know people who recharged their phone for about 10,000 rupees, and the next week they were arrested by the police. So
Right, right. Okay.
do you think the rapid increase in remote work will lead to an increase in RAM server? Yes, I already mentioned this, Shubham. It's as I said, there are a lot of endpoints now for the defenders to defend. So definitely it will.
Right, right. Okay. The next question would be coming up. Yes. I
Yes, certifications definitely help. So certification. So what you need from the HR is, you can say, a door breaker, something that lets your CV to their analysis or onto their desktop. So when you send a mail or somebody refers you, the HRs would probably look at your CV in the mail or the portal there. Now, if it doesn't have some factors, such as, for example, it is not standing out of the ordinary, you're not doing something great, for example, you'll probably be not hired out of the pool that was already there. So you'll have to do something such as door breaker, is what I would like to call. Certificates definitely help because they are a known way. So all certifications such as OSCP, CE, OSC double, OS double E, and stuff like that, CRTP or whatever, they have a known methodology of an exam that you'll have to pass. So every candidate goes to the same level. So if they already hired an OSCP and they know that they're potentially they have this set of skills, you can probably, the HR can probably assume, yeah, the next guy can have the same set of skills as well. So
right, right. Okay. What kind of automation do you have in place for security, both internal and security research? I think this is about CrowdStrike. So
I can't say I can divulge that information. That's pretty serious. No, I don't think I would be able to answer it, Ayush. We kind of keep it very secret about the stuff that we use internally. However, but it is, I can answer for other companies. So even at other companies, there are a lot of you can say there are people who deploy honeypots inside the network, where even if the attacker is inside the network, they when they waste time on the honeypot by doing the same activities that they would potentially do on a user system. So you can deploy honeypots, you can deploy fake networks. So if the attacker keeps scanning and doesn't get proper endpoints, they will also waste their time. So it's our job as defenders to make attackers waste time, because that would eventually let us get them before they do something bad.
right, right. Okay. So I think, Sudhakar, that was the last question. Uh, I think we have an amazing audience in YouTube. We have over 243 people viewing us right now, and thank you so much. I mean, that was such an informative talk. I've been listening throughout, and now I'm interested in security. Like, that was amazing, Sudhakar. Thank you so much.
Yep. All right, thanks guys. I'll drop. Bye bye, have a good day.
Have a good day. Have a good day. Okay, so all right. So that was an amazing talk. We've had the YouTube audience has been so amazing. We've had so many viewers and so many questions. And I mean, I'll just like to personally thank all of you for attending this session. Uh, Before we go, there's just a few things that I'd like to mention. The review 2 is already going on, guys. If you do not know, go to Kumo Space. The review 2 is going on for DevJams, and don't forget to make a submission before 1 p.m. today. You have to submit the GitHub repository links, and uh, anything else you think is relevant, you can submit it there for us, and we will go through your reviews, and we will have a closing ceremony shortly after where we will announce the winners today. So I think that's it. Thank you so much. Thank you so much for attending in the morning, and I'm Hisham, and bye bye.